Alright, so what is a function? You've heard of quadratic functions and linear functions, exponential functions, trigonometric functions, but what makes a function a function? Well, a function is a special type of a relation, uh, which brings us a new definition. What is a relation? A relation is a collection of ordered pairs. Okay, so this would be a relation. This pair, that pair. I'm just picking them at random. Just a bunch. That's too many even. Let's go with this one. That should be good. Okay. So that would be -6, -5, and what is this? This is -4, -3. -2, 1. There's also 0, 5. And we have one more here. That would be 2, 1. Alright, so this is a relation between two things, x and y. Just any collection of an ordered pair. Now, this would also be a relation if we took these points and connected them. That would be this would also be a relation. It's a bunch of points. There's more than just those. There are actually infinitely many points here. I'm sure we'd try to collect this as some sort of a formula to represent it, because this graph would be hard to describe these points. We could have graphed this differently. Alright, and if we look at the red graph and the blue one I'm going to do now, they are different. It's not very easy to see them at the same time. I'll actually separate the blue one. One is a function and one is not. And the reasons will be a tad bit difficult to understand. Alright, so let's just have these points away from here for now. So a relation is just a collection of points. What makes a function a function? Well, a function is a special relationship. Alright, so function is a relation between ordered pairs such that every element in the domain, which is x, relates to one element in the range, which is y. Alright, so in this case this is a function, because if we look at all of the elements in the domain, which the domain in this case is x such that x is equal to, let's take a look at the x values we have. -6, -4, -2. We need more space here. Let's erase that. 0 and 2. Each of these relates to exactly one value in the range. Alright, so we could probably actually represent this a little better. Sometimes it's represented this way, with these two circles. One being, this is not a very good amount of space. I'm going to erase the definition. Right. They're often shown this way for the sake of showing what function means. So we have, in the domain we have -6, -5, negative 4, oh, not negative 5, negative 5 is part of the range. So negative 6 here, with negative 5 in the range. We have negative 4, negative 2, 0, and 2. Those are all elements of the domain, or X. And these are the elements of the range, so negative 5, negative 3, 1, 5, and 1 again. There's no reason to put 1 up there twice. It's the same number. So negative 5, negative 3, 1, and 5. So this is the range, or the y values. Alright, so since every element in the domain has exactly one y value it relates to, negative 6 should only relate to one number. That's 5. Okay? Negative 4 should only relate to one number. In this case, that's negative 3. Negative 2 should only relate to one number, which is 1. 0 should only relate to one number, which is 5. And 2 should relate to only one number, which is 1. Now, 1 in the range relates to two numbers in the domain, but that has nothing to do with the definition of a function. And the reason for that is a function is kind of like a machine that works. When you press an X button, you expect a particular result to occur. Alright, so if we press the 6 button, the negative 6 button, we expect to get negative 5. If we press 0, we expect to get 5. If we press negative 2, we expect to get 1. Alright, so an example of a the example of a non-function would be anywhere where our x value gives us more than one y value. So I'm going to make a small change here. I'm going to change this negative 6 point here to negative 4, negative 5. Okay, so that's this new point, negative 4, negative 5. Now, negative 4, negative 5. So now negative 4, when we press the button, we don't know if we're going to get negative 5 or if we're going to get 3. Why is that negative 3 here? It's supposed to be 3. That's supposed to be 3. Excuse me. Alright, so we don't know if we'll get negative 4 or if we'll get 3. So this is kind of like a broken machine. We don't know what it does. So if one x value gives you more than one y value, it's not a function. And you can see this by looking at the pairs and seeing if there's a repeated x. If one x gives you more than one y, it's not a function. Another thing we do is something called the vertical line test. If we can drop a vertical line, that's a x equals line, and we get two different y values, it fails the vertical line test and is not a function. So let's take a look at some visuals of functions. For instance, if we take this, it will pass the vertical line test. If we draw one vertical line, well, you should really draw infinitely many vertical lines, but if we move it along, you'll see it only hits the function. Actually, kind of here it fails the vertical line test, because one value of x appears to have more than one possibility. So this would not be a function. Alright, so famous examples of non-functions would include a circle. That definitely fails the vertical line test at a whole bunch of points. It doesn't at the very edge. It hits it exactly once here and exactly once here, meaning that those x values only have one y value, but everywhere else it has two. Another famous one would be a parabola that's sideways. That fails on the vertical line test at a whole bunch of places. It passes here, but fails everywhere else. Famous functions. We have lines. A linear equation would pass the vertical line test for all places. Okay. A parabola would pass the vertical line test. It never hits more than once. So yeah, these are functions. Y equals ax plus b, any linear function, any parabola, any cubic function, pretty much any polynomial function, the absolute value function, the square root function, the hyperbolic functions, so the hyperbola, trigonometric functions. Alright, so all of those pass the vertical line test. Ones that don't would be values at lines such as this. X is equal to y squared. That would be the sideways parabola. X is equal to the absolute value of y. That's a sideways absolute value function. There are a couple others that fail. The circle, x squared plus y squared equals 1. So any circle would fail. Well, r squared. All circles fail. So the best way to identify it is to graph the function, or graph the points, and see if they fail the vertical line test. Otherwise, you could just look at the collection of points to determine whether or not you have a function. So, on that note, I'm going to leave this function here, and I'm going to include it in the lesson, and see if you can determine whether or not it is a function before you come into class. Alright, so let me draw this. So we're going to ask in class, hold on, better yet, just want to, here, this is, that is y is equal to the square root of x minus 4, approximately. Is that a function or not? What is its domain? And what is its range?